All right, last part of 9.2 is on symmetry tests, okay? If it's symmetrical about the line theta equals pi halves, which is your y-axis in your brain, you can think of it that way. These are the two tests that you can do. You take r and theta and replace them with r and pi minus theta, or you replace them with negative r, negative theta. And once you simplify, and you're going to probably need to use some identities, when you get the same thing that you started with, that proves that it's symmetrical, okay? Symmetrical about the polar axis, this is your x-axis. You have, again, two test possibilities, and then symmetrical about the polar, symmetrical about the origin. These are your two tests, okay? So in the book, they're going to tell you exactly what kind of test to do. Are you going to do this one, or this one? And then you have two choices on either one, okay? The directions for your homework say use one of the three tests to prove the specified symmetry. Well, I just picked a graph because they actually didn't do any examples of this in the book. So I picked this graph, and we're going to graph it so you can see that this particular graph is symmetrical about the polar axis. Polar axis. So I have two tests to perform. I can do this one or I can do this one. This one is a whole lot simpler, so I'm going to stick with that one. So I have r equals 2 cosine of 3 times a negative theta, which, if you go back to your identity sheet, the cosine of negative theta is the same as the cosine of theta, so it's the exact same thing as cosine of 3 theta. These are the same, so we proved polar axis symmetry. Okay, this graph, I have 3 sine of 2 theta. I don't know why, I just happened to pick 2 roses. This graph is symmetrical about the polar axis. This is symmetrical about the line theta equals pi halves, and it's symmetrical about the origin. This particular one is. So, or about the pole. So I'm going to choose the pole. And again, between the two, I'm going to do this one just to remind you of how to do the sign of a sum identity. So r equals 3 times the sine of 2 times pi plus theta, or 3 times the sine of 2 pi plus 2 theta. So the sign of a sum identity says I have the sine cosine, cosine, sine, sine of 2 pi is 0. Cosine of 2 pi is 1. So 0 times cosine is gone. I'm left with 3 times the sine of 2 theta. Again, have the, I'll go this way, same. So I just proved that I have pole symmetry. And that's all you're doing for these tests. You could have done the other one. It would have been shorter, okay? But, excuse me, you can choose either test.